Hello everybody, I'm going to continue on from the introductory video towards talking mostly about deductive logic or deductive reasoning. And this is what we are going to be using moving forward. Because again, we're not biology students in a lab making controlled experiments to have controlled observations to generalize into a finding. That's not what we can do. We're people taking some truths that we know and applying it to new knowledge. We don't know the answer to this, but it's kind of like this other thing, so let's put it together and come up with an answer. We use deductive reasoning every single day. So we use the truth that we know through our experience, through trial and error in the past, which is induction, and we apply that to the truth, to a new truth, to something new, unknown, related experiences. That's deduction. So we don't know it, we've never known this experience, but we know it's like this other thing, and we're going to apply what we know to it. We do this every single day. Every time someone says, "Oh, why do we bother learning algebra in school? When do we ever use algebra in everyday life?" And I get so frustrated with mathematicians for not selling it better. We do use algebra every single day. When we make a decision missing a piece of evidence, we are solving for X. So maybe we don't do the mathematical calculations, but we're using the same principles. The example here is somewhere like Home Depot. If you're not a super contractor who spends all your time at Home Depot, you probably walk around crazy like you don't know where anything is. Where would this possible thing go? But we do kind of deduce where we need to go. They have 100 different aisles. We usually don't walk up and down every single one of them. We kind of know where to go based on our solving for X. What could possibly be here? Think of yourself on a road trip and it's really hot and you really want some popsicles or something. So you stop at this grocery store and you've never been to this grocery store ever before, but you find yourself gravitating towards the center of the grocery store. Why? Every other grocery store we've ever been at has the freezer aisle in the middle. So we're using what we know about grocery store setups, that freezers tend to be in the middle or the back, and we go straight there because that's where we know the ice cream and the popsicles are going to be. We don't walk up and down mindlessly every single aisle until we find what we want. We've deduced where we're going to go. We've taken what we know and applied it to this new situation. We use this for wayfinding, we use it for diagnoses, we use it to identify things by a few different known traits. My favorite story here is from my own experience in seminar as a student at St. Mary's. And my leader in seminar was the late Professor Albert Dragstadt, who I considered like my guru in deductive thinking. There were so many times he proved he was just a wizard at deduction and figuring something out about someone based on the few little things that he knew about them and applying it to his general knowledge. The story I have is we were in seminar and I said something about y'all. And he looked at me kind of funny and he said, "Are you from Oakland?" I'm like, well, what does that have to do with anything in seminar right now? But I was curious of how he knew that. I can tell you as a professor, our rosters do not have your hometowns. I'm like, I am. How did you know that? And he explained it. And what he explained was deduction. That he had in his presence a young person with a traditionally California accent who had said the word y'all. And he also knows that even though it's not very popular in California, after the Great Migration, Second Great Migration, particularly of African Americans from the South to California for jobs during World War II, particularly in Oakland and Richmond, a lot of people with Southern accents were going to school and being involved in the communities. And people started to pick that up. So he knew by looking at me and knowing my age, and hearing my accent of not being a Southern accent and hearing me say that word y'all, that I must be from one of those two places, either Oakland or Richmond. It was kind of magical to me. And it didn't really, it doesn't make sense in the long term that you can identify someone by a word they say, but it proves the power of having a knowledge base, picking up a little piece of information and putting the two together. Really, really important to be able to do. One of the ways we can check our logic, specifically in deductive logic, is with the use of a syllogism, and these will look familiar in just a minute. A syllogism itself is not an argument. They're deductive tools. They're very mathematical. They're cut and paste, lines and drawings, and really putting your words into an order where you can double check your logic. It starts with a major premise. Remember these words, premises and conclusions. Very deductive logic. The major premise is the most general statement. It has the community acceptance. It's all encompassing. It's the truth, the absolute truth that we are then coming down from. And then there's also the minor premise, this little piece of little thing, that one little observation you've made, that you're then going to apply the two together. That's the major premise and the minor premise. Those together lead you to what is the therefore statement, the conclusion. This is where it gets mathematical, and this is a area you really want to, write this down, remember this. The major premise is a general term plus term 1 and term 2. The minor premise is when you introduce the new term plus that first other term. And the conclusion is you're applying that new term again to number 2. What? Huh? Don't worry. Write this down. It will make sense in just a minute. We always ask of a syllogism, are our terms distributed correctly? And we ask, does a reasonable community agree with the major premise? So these are the two questions you'll always ask. And the G plus 1 plus 2 and T plus 1, that is making sure that our terms are distributed correctly. If that's distributed correctly, it's a valid syllogism. It's valid logic. If we can all agree with the major premise, if we can agree with that, then it's sound logic. We want arguments that are both valid and sound. This should look familiar, the most famous syllogism of them all. All men are mortal. Your general term is all. Your general term should always be all. Men is that second idea being introduced, or the first idea introduced, and mortal is the second idea introduced. Now we're going to apply that to the more specific. So we've got this all-encompassing truth, this major premise that all men are mortal. Well, Socrates is a man. Okay, this is something else we've introduced Socrates. Therefore, Socrates is mortal. We can deduce that Socrates is in fact mortal, that Socrates is a person who will die, based on the fact that we know that Socrates is a man and that all men are mortal.